A large piece of poster board paper, see how large that is? No, I cut out this little piece so I could demonstrate some stuff, is 40 inches wide and 55 inches long, and we're gonna do something amazing with this. So let's go ahead and label a couple things before we get too far into this. So 40 inches wide, this is 40, and the length is 55. So width is 40, length is 55. A square is going to be cut out of each corner, and the remaining paper will be folded into a rectangular box with no lid so you can keep your family of miniature hairless trolls in it. Like, what? Okay, the problem just got suddenly weird, but we can ignore what you're going to put in the box or not put in the box. But here's what's about to happen. You're going to cut this corner out of all four corners, and it's going to be a square. I'll do that to the best of my ability. So this little square, you can see it right there, is X wide and X long. And I'm cutting the corners off of this rectangle, singing a song. Boing. Now we have this. And what I want to do is fold up the edges and make a little box. It's not going to have a lid, and that's okay. Trolls can't jump. Everybody knows that, especially hairless trolls. So there we go. We're going to make a little box. Isn't that cute? Notice it's three-dimensional now. That's going to come in handy. So let's keep reading. What value of X will maximize the volume of the box? What I don't know is the volume of the box. So that is going to be my second equation. Volume. All right, so let's just go ahead and list that. The volume of this box is, well, length times width times height, right? So the width of this, I would love to say it's 40, but it's actually not anymore. It was 40, but then we chopped off this length and this length. So we cut off X and X from 40. So the volume is not 40. It is 40 minus X minus X. That is 40 minus 2X. All right, the length is 55. No, it's not. It's 55 minus X minus X. That would be 55 minus 2X. Okay, well, what's the height of this box? Well, let's do a little foldy fold. This was X, right? That length is X all the way around. So X gets folded up, and that is now the height. Okay, so usually we need a first equation, and I think I had said erroneously in another video or two that we always have two equations, and this time we don't, because we actually only have one variable. I know we have V, but we only have X. We don't have R and H or X and Y or A and B. We have X. So sometimes you don't have an equation, and if I accidentally lied to you earlier, I am very sorry. So I take it back. And we need to take the derivative of this, which would involve product-y, and chain, actually no chain, but it would just be crazy. Let's not. Let's just FOIL everything out. So 40 times 55, which I don't know off the top of my head, and I'm embarrassed, 2,200. 2,200 when I multiply those, and I'll go ahead and distribute the X, so X. And then negative 80 minus 110 is negative 190 X times X. And then we're going to have 2 times 2, so that'll give me 4X squared, but that other X makes it cubed. So feel free to check behind me on that, and put your comments in the comment box if I made a mistake. I'm kidding, I didn't. As you can see, I was just double checking because it's a video and I didn't want to start it all over. As much as I love doing this stuff, I'll proceed. So we have simplified. Let's find the derivative now. So 2,200 minus 380x plus 12x squared. Okay. What we're going to do is set this equal to 0 and solve, and this one is quadratic. And most of the time when we see a quadratic, we try to factor it. Good luck with that. Really, good luck with that. What I am going to do is make things a little bit easier by dividing everything by the same number if I can. I know 2 goes into all of those for sure. I know 4 goes into all of those, and that is all, because 3 goes into that, but not this or this. Okay, do you know how to figure out if a number is divisible by 3 or not? Anyone ever told you? Well, now you're going to find out. 81 is divisible by 3. Here's why. 8 plus 1 is 9. 9 is divisible by 3. 879 and then 231. 879,231 is divisible by 3, and here's why. 8 plus 7, this has nothing to do with calculus, although it might have everything to do with calculus. That's 30. 30 is divisible by 3. Done. Isn't that beautiful? Okay, now you know. We're going to divide everything by 4. So 2200 divided by 4 is a number that I should be able to do in my head, but it's been a long day. Good day, but a long day. 380 divided by 4 is 95. Yep, should have been able to do that one in my head. 12 divided by 4, I better be able to do this one. There we go. That's what we have. And we will figure out what that is. And we are setting it equal to 0. We're going to solve it. Does it factor? I don't even know. There's a way to tell if it factors too. And actually, off camera, I'm going to figure that out really quickly and see if it factors or not. Not that I'm going to factor it because I don't feel like it. Nope, doesn't factor. Just does not factor. No matter how hard you try, it's not going to factor. All right, so it doesn't factor. There's a way to tell. I'm leaving you hanging. Hang around at the end of the video. I'll tell you what I did. But we are going to solve this. I am going to grab a calculator visibly at this point. And we could use the quadratic formula, but just let's proceed with graphing. So 550 minus 995, x plus 3x squared. We'll do it that way. And I'm going to just do a standard window and see what I'm up against here. I'm looking for x-intercepts, by the way. I think that's fairly obvious because this equals 0. There's 1. And that's all I see. And do we have anything? There we go. There's 1, and there's got to be another one somewhere. I'm going to increase the window range, the x maximum. I should say window domain. And we're going to go to 100. Let's do that. We'll see things a little bit better. There they are. There's 1. There's 1. I don't know what they are, but I'm about to find out. So x equals a couple things. And let's find the zeros. Okay, left bound to go to the left of it. Where is it? I can't see it, but look down here in the bottom. You can see those numbers. And, oh, we passed it. It might appear briefly. There it went, there it went, see? So I'm going to go to the left of it, and I am to the left of it. There it is, and there's to the left of it, and there's to the right of it, and we'll press enter. And we have 7.626. There's one answer. And then we're going to have a second answer, and that is also a 0. So let's go to the left of it, but I'm pressing the right arrow key just so I can be to the left of that. By the way, this looks like, oh, there it is. If this is 100, then this is probably 25-ish. So we can just pick a number like that and then go to the right of it. And it is, well, 24. 24.041. Whoops, 1. Ah, looks like a 7. No, it looks like a T. 4.1. All right, here we go. Let's figure out which one of these answers works and which one we should toss out. What value of x will maximize the volume of the box? What is that volume? Let's see. Is it possible for me to have a, use your imagination here, 40-inch wide piece of paper and cut 7.6. We'll call it 7.5 for conversational purposes. To cut 7.5 inches off here and 7.5 inches off here out of 40, yeah, we could do that. Looks good to me. Is it possible to have a 40-inch wide piece of paper and cut 24 inches here and 24 inches here? No, because that, when doubled, is more than 40. You would be cutting more than half off here and more than half off here. I don't even know what that would look like in another dimension. Just no, that one's not going to work. So we need to find that volume. So now let's take that value and plug it back in, which means I probably need to find it exactly again. Let's find that 0 between 0 and 10. There we go. By the way, when it says left bound and right bound, you can press in numbers. And now that I know what it is, I went like 0 to 10 and narrowed it right down. So there we go. Right now, the calculator thinks that's x. I'm going to quit, and I never like to leave something stored as x, just in case I need to graph something and mess it up. Although the very next thing I do is to type this in. Still, my x, I'm going to store it as a, because it's just in case. And let's figure out that volume. That volume is 40 minus 2a, or x. 55 minus 2a times a. Ah, not to the negative one. Oh, don't reciprocate. Stop reciprocating. Get down, get down. 7501.57. Oh, I'm glad this happened. Okay, always 3 decimal places, unless your decimal truncates. Like if this would have truly been 7501.57, done, like done, that's it, then you can stop there. But because it keeps going, we need to tell the person that's grading our paper, me in this case, the person that's grading our paper, that we know that this thing has been rounded to 3 decimal places by putting a 0 there. So there we go. And what value of x will maximize the value of the box? What is that volume? We've got the x, we've got the volume, and let's call it what it is. This is cubic inches, and this is inches. And that's it. All right. The official part of the lesson is over, and so stop the video if you want to, but I'm going to tell you how I knew that this didn't factor, and here's how. We use this tiny little box that I made for hairless trolls. Negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. That should totally look familiar to you. It's very sloppily written. When you used the quadratic formula to solve quadratic equations, you would end up with irrational answers when this could not be square rooted. All right, so let's talk about it. This used to be a whole lesson we did way back in the day in a class called Algebra 2. It was fun. That little guy right there was called the discriminant. There, let's hyphenate it. Discriminant. Because it discriminated against the different types of answers we would get. We would get irrational answers or rational answers depending on what this was. So if I plugged my A, B, and C into this and I got a perfect square, then I would get rational answers and it would factor. And that's actually what I did. So here's A, B, and C. So here's what was in my calculator. Negative 95 squared. Actually, I left the negative off because it's going to become positive. Minus 4 times 3 times 550, and I got that, and I'm like, ooh, does that square root? Raise it to the 1/2 or square root it, and no, it does not. That is not a perfect square, so this does not factor. Just saying. Good to know.